Welcome again to Gym Athletics, and today I'm going to be taking you on surface area of solid shapes. Now, in my previous videos I talked about solid shape, and there I showed you some solid shapes that we have, most especially in mathematics. But today we are going to be talking about the surface areas of this solid shape. Now here, take for example, I have a cuboid. Now this is a cuboid. Now when we say surface areas, what do we mean? We are talking about the surface of this cuboid. Now take a look at this. If I'm to ask, how many surfaces does this cuboid have? You can see I have one here, I have two, here, three, I have another behind, four, then five, and six. So this cuboid has 6 surfaces. This cuboid has 6 surfaces. So when we talk about surface areas, that's just what we mean. We mean the surfaces of this solid shape. Now when you look at this also, you will notice that each of the surfaces are rectangles. And that's why we call it cuboid. That's why we call it cuboid, because each of the surfaces are rectangles. I also have here a cylinder. Now, what are the surfaces of this cylinder? You can see this is one surface, this is another surface, and then the round body also is part of the surfaces of this cylinder. So you can see that here is a circle, it has a circular surface. We also have a circular surface here, and then a round body, which makes up the third part or the third surface area. I have here a cube. You can see also a cube here. It has 6 surfaces. It has 6 surfaces. And what makes it a cube is because each of these surfaces are squares. I believe you know that. So you can see we have one here. That's 2, 3, 4. We have another here, 5. And then finally here, 6. So these are regarded as surface areas. They are regarded as surfaces of this shape. Now I also have another here. If you can remember, I call this a triangular pyramid. This is a triangular pyramid. Now, what are the surfaces? Now you can see we have a surface here, 1. We have another surface here, 2, which is triangular in shape. We have the third one here, 3, which is triangular in shape, and then the base also is a triangle. The base also is a triangle. So looking at this triangular pyramid, it has 4 surfaces. It has 4 surfaces. So when we are talking about surface areas, what are we simply saying? We're trying to find the area of these surfaces. The area of these surfaces. Now, you have to be very good at knowing the properties of each of these shapes to be able to find the surface areas of this shape. Now, take a look at this now. You will notice that what makes it a cuboid is because all of the surfaces are triangle. That's what makes it a cuboid. So you will notice that here, this surface is not the same as this surface. Although this surface is a triangle, and likewise this surface is a rectangle, and likewise this is a rectangle, but they are not the same. And that's because they don't have the same dimension from it. So you can take a look at this. So you can see, and you can see this also. Right? So now I would like you to know that this surface is equal to this surface, of course. And likewise, this surface is also equal to this surface. Finally, this is also equal to this. So now if you know a cuboid very well, you'll be able to find the surface area. We have a cylinder here. This is a cylinder here. Now, you notice that this surface is also equal to this surface. And that's what makes it a cylinder. So you can see a cylinder has 3 surfaces. We have a circular base here. We also have probably a circular top here. And then we now have the round body. And that is what makes it a cylinder. So today, we are going to be talking about the surface areas of this shape. Now let me give you an example here. Take for example, this is a cuboid now. Now this cuboid has 6 surfaces, of course. You can see it's closed. It has 6 surfaces. You can see that. It has 6 surfaces. So if I'm told to find the surface area of this cube, how will I go about that? First, I will have to know the dimension of this cube. So take, for example, now, I have this cube here. I'm going to draw that on the board. And the dimensions are, let's say, 5 centimeter. Now, don't forget that for a cube, all the edges, otherwise called the sides, all the sides are equal. So if this is 5, this is also 5. And anywhere I turn, any of the surfaces I turn, it will always be 5. Why? 5 centimeter. Why? That's because a cube is made up of square surfaces. It's made up of square surfaces, and for a square, all the sides are equal. So if I'm told to find the surface area of this cube, so I just drew this down here, using this as an A. Now, look at it now. We have 5 centimeter here, and we are told to find the surface area. That is the total surface area. So first, I'm going to find the surface area for one of the surfaces. So I'm going to have surface area. Now, if this is a square, what is the formula for calculating the area of a square? It is L raised to power 2. That is to say, length times length. So this is the length, so we have 5 square. That makes this to be 25 centimeter square. So what does that mean? It means the area of this surface, I just calculated for one, for this surface is 25 centimeter square. But don't forget, remember that the cube has 6 surfaces. We have 1 here, 2, 3, 4, 5, and 6, and all the surfaces are the same. Since all the surfaces are the same, so what would be the total surface area of this cube? Total surface area of the cube, we have one of the surface area is 25 centimeter, and we have 6 surfaces. So that simply means 6 times 25 centimeter squared. And when we multiply this, that gives us 150 centimeter squared. So the total surface area of this cube, is 150 centimeter squared. I believe you understand what I'm trying to say. So now take a look at this cuboid again, and you discover that it's quite easy to find the total surface area. But for this, remember I said earlier on that you have to know the solid shape well for you to be able to find the total surface area. So just a recap on that. Remember I said this surface area is the same with this surface area. Why? This surface area is same with this surface area. And finally, this surface area same with this. So if you are told to find the surface area of this cuboid, you have to be mindful of the dimension. And that will be able to help you find the total surface area of this cuboid. So today I'm going to be bringing again another idea of maybe open surfaces. We have some solid shapes that have open, maybe a surface is open. Like take for example the swimming pool in your house. Maybe the swimming pool, you will notice that it has walls and it has a floor. So here, I'm going to use this carton as an aid, just to paint a picture of what I'm trying to say. So you can see that, what shape is this carton? This is a cuboid. This is a cuboid. How do I know that? You notice that this is a rectangle. You can see this is also a rectangle. This is also a rectangle, and likewise you can see that all of the surfaces are rectangle. But we have one of the surfaces. It is open actually. We have it open. So this is just a picture of the swimming pool in your house. You can see that. So if I'm to ask now, how many surfaces does this particular solid shape have? So let's go ahead and count. We have 1, 2, 3, 4, and the bottom 5. So you can see that it has 5 surfaces, excluding the top, because it is open, excluding the top. So it has 5 surfaces. So this is just a picture of another shape. Now this will help us to be able to solve this question. Now, what does this question simply say? And of course, you know, in geomathematics, we deal majorly with word problem questions. Now, remember, I've made videos on word problem, on how to solve word problems. And remember, I said you have to read the question gradually and understand what the question is saying. So, first, let us have the question like this. A swimming pool is 8 meters long, 6 meters wide, and 1.5 meter deep. Now I have to understand what that simply means. Now I know a swimming pool, right? I know a swimming pool, and it has an open surface, just like this. It has an open surface, just like this. So now I'm going to use this carton as an example, or to just help create a picture of what this question is saying. Now, you can see that it said the swimming pool is 8 meters long. So let's assume that this is a swimming pool. It is long, which is the length. So I'm going to have 8 meters here. And then they said 6 meters wide. Now, this is how long it is. Now, this is how wide it is, which is the width or the breadth. So I'm going to say this is 6 meters wide. And then the question went further to say it is 1.5 meter deep. Now look at it. If you're standing at the top, you talk about depth, which is deep. Deep. If you're standing at the top here, you talk about deep. If you're standing at the top, you talk about deep. So that's why we said it is 1.5 meter deep. So the depth is just this. So I have 1.5 meters. So you can see that I've been able to bring out the 3 dimensions that makes this solid shape from that question. We have 8 meters, 6 meters, and then 1.5 meters. Now you can see that this is a 3-dimensional shape. Now, moving forward again, the question says the water-resistant paint needed for the pool cost 2,500 naira per square meter. What do they mean? Now, they brought in a painter, and the painter wants to paint the walls of this swimming pool. Now, and he needs, or she needs, whoever the person is, needs a water-resistant paint. Now, to paint every square meter, it costs 2,500 naira. Every square meter will cost 2,500 naira. So, if he's going to paint the wall here now, going to paint the wall in here, want to paint the wall in here, he or she is going to find the area of this wall, and likewise this, and likewise this, and this, and of course the floor also, to tell the amount that that's the total amount, because each square meter, that is to say meter square, each square meter costs 2,500 naira. I believe with this illustration you have a picture of what this question is saying. So the first part is, how much will it cost to paint the interior surfaces of the pool? Now, in word problem, we'll take it gradually. So with this, I've been able to explain what the question is saying. So now let's go ahead to solve the question together. So I have my solution here. Number 1, I'm going to solve this now. Now first, I'm going to find the surface area of each of these each of these surfaces. I'm going to find the surface area of each of these surfaces. Sum it up together, right? I will sum it up together, and that will give me an idea of how much it will cost to paint the swimming pool. So now, looking at this again, this surface, remember I told you for a cuboid, you have to know not even for a cuboid alone, but for all total surfaces, for all solid shape, you have to know the solid shape well to be able to find the surface area. Now, when you look at this, I hope you won't be confused, knowing that this is 8 meter, while this is 1.5 meter. When I turn to this side, this is 6 meter, and this is 1.5 meters. Likewise, all the other side. Now, this side is equal to this side. So I'm going to call this side A, which is as well equal to side B here, right? So this is also A too, because they are both equal. I'm going to call this side B, and this is also side B. They are both equal. Remember I said that they are both equal. They are both equal. So now let us find the area of side A first. So area or surface area of side A. Now I'm going to find one of the side. Now, of course, it is length times breadth. That gives me 8 times 1.5, which gives me 8 times 1.5, and that is 2, and that gives me 120 meter. That should be 12, rather. That should be 12 meter square. So the area here is 12 meter square. Do you really understand that? Yes, I believe you do. Now, don't forget, this is just the surface area. We also have another here, and they are both equal. So I'm going to say surface area. That's surface area. The surface area now of A's, the one with A's now. That will be 2 times 12 meter square, and that gives me 24 meter square. So the area here, 24 meter square. Now let's also go ahead to find the surface area of B. So surface area of B. Now I'm going to find for one of them. Now you can see that this is 6 meter and this is 1.5 meter. So I'm going to have, of course, you know it is length times breadth, and that becomes 6 times 1.5 meter. Now 6 times 1.5 meter, that gives me 9 meter square. Then what is the surface of the other? Now this is 9 meter square. Of course, this will also be 9 meter square. So when I have the total of them, area of B's, I'll call that B's now, and that will be 2 times 9 meter square. That gives me 18 meter square. So you can see that the total surface area of this and this, that makes up 24 meter square. And likewise, the surface area of this and this, that makes up 18 meter square. But we're not done. These are just for 4 surfaces. How about the base? Now, looking at the base, let's go together now to look at the base. Don't forget, this is 8 meters, right? Yes, of course. And you can see that this is 6 meters. So if this is 8 meters, this makes this to be 8 meters. And if this is 6 meters, this makes this to be 6 meters. So of course, I have my dimension already. That is 8 and 8 meter by 6 meters. So surface area of the base, surface area of base, that would be length times breadth, which you know, that's 8 meter times 6 meters, and that gives us a total of 48 meter square. So you see, now we've been able to find the surface areas, that's the surface areas of each of these surfaces. So we are going to sum that up together to tell us the total surface area of the swimming pool. So total surface area becomes, now for the whole of A's we have 24 plus the whole of B's we have 18, and then plus the surface area of the base, which is 48. Now when I total that together, what am I going to have? This will be 38 plus 4, that is 42. 42 plus 40, that gives me 82, and 82 plus 8, that gives me 90. So this is 90 meter square. I believe you understand the addition I just made now. So that is 90 meters square. Now, that is the total surface area of the swimming pool. So what the painter is going to do now, the painter has 90 meters square surfaces to paint. But then the question says each square meter costs 2,500 naira. Each square meter costs 2,500 naira. So how much will it cost to paint the interior surfaces of the swimming pool? So if each, that is what does each mean? It means every 1 square meter costs 2,500 naira. Then 90 meters square, how much will it cost? So to answer the first question, cost of painting the interior will now be 90, yes, times 2,500 naira. That's because every 1 meter square costs 2,500 naira. Then when we have 90, how much will that be? So multiplying this, we have 25 times 9 and 9 times 5, that's 45. 5 for the 4 here, 9 times 2, 18. 18 plus 2, that gives me 22, right? Good. So I have 2, so this is the 5 here, and I have 3 zeros here, so I'm going to have 1, 2, 3. So that gives me a total of 225,000 naira. So to paint the swimming pool will cost 225,000 naira. Now looking at the B part of the question, it says, how many liters of water will be needed to fill it? How many liters of water will be needed to fill it? In my previous video, I talked about the volume of cuboids, right? Yes, so in case you missed that, you can go again and to check on my previous videos and you will find that there. So, but don't forget, there's something very important I said in that previous video, which is, I said that every 1,000 centimeter cube equals 1 liter. And here they said, how many liters? How many liters? Now, that would be quite a chunky one to work out, but then let's see how far we can go with that. So how many liters of water will fill it up? Don't forget, I said, just a recap, that 1,000 centimeter cube now equals 1 liter for solid shape. So we're going to go back again to know what will be the volume of this cuboid. Don't forget, volume of cuboid, which is length times breadth times height. So what's the length? Let me help you with this again. Of course, how long it is 8 meters. So I have 8 meters, which of course I can as well change it to, yes, okay, let me just have that first. 8 meters times, what is the breadth? The breadth is 6 meters times, what is the height? The height is 1.5 meters. So I think I would like to change it to centimeter here. I would like to change to centimeter since this is in centimeter cube. So what I'm going to have here, 8 meters, same as 800 centimeter. And this is also because for every 1 meter is equivalent to 100 centimeter. Now this is 600 centimeter times, now 1.5 times 100, that gives me, that gives me 150 centimeter. So I'm going to multiply through to tell me the volume in centimeter cube. So take a look at this now. I have 8, oh, okay fine, let's say 6 times 15, that gives me 90, I guess. Yes, that's 90.